Hello viewers, welcome to another session of TechPitch Tutorial. Today we are going to be implementing ASA Active Standby, which we will plug into Nexus switches running vPC. But before we go into the implementation, I want to show us my blog and I want to implore us to visit techpitch.co.uk. That's my blog, and subscribe to my mailing list. So whenever I release or publish a new tutorial, you are going to receive an email alert telling you that a new tutorial has been published. I have several tutorials here on C-Square's implementation, on FTD, identity awareness configuration, FTD, malware policy, IPS, site-to-site configuration, NGIPS, several kind of tutorials, even remote access VPN using any connect and the rest like that, TACACs and that. Also, I have my YouTube channel here, TechPitch. Kindly subscribe. So this is where I upload all my tutorial videos. You can see there are a lot of videos here, and there are lots more still coming up. I still have video coming up on Cisco TrustSec, on Checkpoint, on Palo Alto, Fortinet, network automation, Juniper SRX, and the rest like that. So kindly subscribe. So let's go to business. So this is the topology we are going to be working with during this session. So here we have two Nexus switches, and the two switches we have vPC implemented between them. So they are going to be seen logically, the two switches are going to be seen as one. And this is the inside segment. I have VLAN 10, which represents inside 1, and VLAN 20, which represents inside 2. So on the ASA here, on this inside segment of the ASA, we have port channel 1. So port channel 1 will consist of two sub interfaces. One will represent inside 1, which will be VLAN 10, and the other sub interface will represent inside 2, which is going to be VLAN 20. And this is going to be the outside segment of the ASA. So let's quickly go to implementation. I'm going to log into my Nexus. So the first thing I will do is I'm going to enable vPC feature, and there are two features, so vPC and LACP. So those are the two features I need to implement my vPC. So the first thing I'm going to do, I'm going to configure my peerkeeper live interface rather. So I'm going to put my peerkeeper live interface on a separate VRF. It's not going to be on global VRF, so I'll just create a VRF context PKA, peerkeeper live. And my keeper live interface is Ethernet 1.4. No switch port. I want to turn it to layer 3 interface. VRF member PKA, IP address 111.1.30, so that'll be 252.252. No shot. So I'll create my vPC domain 1, and I can also assign priority, say priority 5. The Nexus with the lower priority is going to be the primary, while the other will be the secondary. Peerkeeper live, destination 1112. The destination is going to be on the Nexus 2, which is 1112, and the source is going to be this Nexus 1.1.1.1. Let me bring my console here, and they're going to be on VRF PKA. So that's it. Should run vPC, should run interface Ethernet 1.4. So that's also the next thing is to configure our peer link. Interface port channel 1, switch port mode trunk, Switch port mode trunk, switch port trunk, allowed VLAN 10 and 20. That's the VLAN I want to consider, actually VLAN 10 and 20. So spanning tree port type is going to be network. There is no shots. Interface Ethernet 1, 2, so 3. So the two interfaces are supposed to be a member of channel group 1, that's port channel 1. So yes. Okay, no shots, and now see channel group 1 mode active. So that should be all. Let me run show port channel summary. Yeah, not yet have. So actually it can't be all because the other side haven't been configured. So I'll just quickly go there. Let me do show run. Okay. On the other side, we reach of vPC, reach of LACP. I need those two features, and vPC domain 1, peer keep alive. Destination is going to be the other switch. Destination 1111, and source is going to be 1112. VRF peer keep alive. I've not created the VRF, so that's all. VRF context PKA. So interface Ethernet 1.4. I need to create the IP on the interface and add it to the VRF member PKA. No switch ports. I need to turn it to layer 3. VRF member PKA. And IP address will be 1112.30. No shorts. Should run interface Ethernet 1.4. Should run vPC. So now let me do the peer link. Interface port channel 1, switch port mode trunk, switch port trunk, allowed VLAN 10 and 20, spanning tree port type network, no shots, interface Ethernet 1, 2 to 3, switch port mode trunk, no shots, channel group 1 mode active. So show port channel summary. Port channel is down. Okay, now it's on S. Let's see. Show port channel summary. Okay, port channels are up now. But the show run interface port channel 1. Okay, peer is alive. Peer link not configured. Yeah, show run interface port channel 1. interface port channel 1, I need to have vPC peer link. Should run interface port channel 1, interface port channel 1, vPC peer link. So that command will make port channel 1 the peer link. So without that command, that means I still don't have peer link configured. So show port channel summary, it should be up. 1 is down. Why do we have 1 down? 2. Okay, they are now up. Show vPC. Oh, fine. Excellent. Okay, vPC domain ID 1. Peer adjacency formed. Okay. Peer is alive. Configuration, consistency, successes. Okay. So I'm fine. Fine. Show vPC role. This is the primary. As you can see, because I gave it a priority of 5. Let's come here to Nexus 2. Show vPC role. You can see this is secondary, and this is having the default row priority, and this is the peer, which is Nexus 1. This is the details of Nexus 1. It's having priority of 5 configured, which I did, but this I didn't configure any priority for it, so it picked up the default priority. So I think we are fine from the vPC perspective. So what I'll do now, VLAN 10. You can see there's no VLAN, there's no active VLAN here. So VLAN 10 and VLAN 20. So show vPC. Okay. It's going to be active very soon. So now I've done that. The vPC have been taken care of. Now interface Ethernet 1.1. Here I want to configure the inside segment. Switch ports. For this, I'm going to make it a trunk port. Channel group 1 mode active. Oh, sorry. It's going to be another channel group, and let me just make that. I'm going to make that 100. Sorry. Okay, mode actives. So 100. Should run interface Ethernet 1.1. Should run Ethernet 1.1. I want it to be active, so I'm going to remove that so that I can negotiate LACP itself. 100 channel group 100 mode active. Okay, that's that. Interface port channel 100. Switch port mode trunk. Switch port trunk. Allowed VLAN 10 and 20. And I'll add it to vPC 100. I prefer to use a port channel ID for consistency's sake. So vPC 100, no shots. So that being done, let me go to Nexus 2 and configure this interface on Nexus 2 also. And before I do that, should run interface Ethernet 1.1. Okay, should run interface port channel 1. Sorry, port channel 100. Okay, that's cool. So back to Nexus 2. interface Ethernet 1.4, no short, channel group 100 mode active, interface port channel 100, switch port mode trunk, switch port. Oh, is it on layer 3? Okay, let me change to layer 2. Switch port mode trunk, switch port trunk, allowed VLAN. Okay, allowed VLAN 10 and 20, and it's going to be vPC 100. Show run interface Ethernet 1.4. Okay, show run interface port channel 100. Okay, fine, belongs to vPC 100, and here also port channel 100 belongs to same vPC 100. Show port channel summary. This is suspended. Show port channel summary. This is also suspended. So let's go to our internal switch. Let's configure port channel interface range channel 0021. Okay, it should not be short by default. Channel group. Okay, let me just make it 100. Also mode active. Oh, sorry, what was that? Because it failed on it as a. Okay. What's this error about? 100 mode. Okay, let me do this. Let me see if it's an issue. My virtual switch 100 mode active. Command rejected, invalid group slot. Oh, fine. That's a problem. Interface. Let me go back to my range. Ethernet 0021. Channel group. Let me use one. I don't know why it's not taking 100. Creating port channel 1. And I have between 1 to 255. But okay, that's fine. No shorts. So interface port channel 1. Switch port mode trunk. Oh, I need to do switch port trunk encapsulation. On this, I need to specify the encapsulation. .1q. Switch port mode trunk. No short, switch port allowed VLAN 10 and 20. Switch port trunk. Allow VLAN 10 and 20. No shorts, so I'll create my VLAN 10, VLAN 20. Show run interface port channel 1. Do show run interface port channel 1. Do show run interface Ethernet 00 and 01. So we should be fine. I think this is show Ether channel summary. Do show Ether channel summary. One is still being suspended. Why? Okay, let me do show vPC. Okay, please check so you can for. Okay, there's something wrong. Consistency reason of down vPC for type 2 consistency. I'm having type 2 consistency issue. Show vPC consistency parameters global. So let me compare the two. Okay. 5 VLAN 10, VLAN 20, both VLANs are allowed. Okay, where is the consistency coming from? Show vPC. Please check. Show consistency vPC number for the consistency reason of that vPC and for type 2 consistency reasons. Okay, show vPC consistency parameters vPC 100. See what's problem here. Okay, now show run interface for channel 100. Show run interface for channel 100. Okay, show run interface channel 211. Motron Calablan 1020 100 mode active. Show run interface. Oh, that's the problem. Interface port channel 100. Interface, it's one doesn't have anything. I thought I configured it. Okay, channel group 100 mode active. I don't think it will join now because I've configured port channel 100. So I need to put that same parameters I have on port channel 100 on this guy, which is this, excluding the vPC. So I'll do this. So it should be able to join port channel 100 now. Okay, that should be it. Show run interface port channel 100. Show run interface Ethernet 11. Okay, fine. Right now show vPC. Does he have the inconsistency? Show port channel summary. Show port channel summary. Okay, it's up here. My port channel 100 Ethernet 11 is up here. Let me check this again. Okay, what I configured was 1.4. 1.4 is not supposed to be here. My God, that was a mistake I made. 1.4 is my keep alive interface. Default interface Ethernet 1.4. Interface Ethernet 1.4. VRF member PKA. There should be no switch. I should make it layer 3. VRF member PKA. Okay. IP address 1112/30. Now do no short. Show port channel summary. Okay, my vPC status should be all fine. Show vPC. Okay, the pair is now up. vPC, what reason is that? Show port channel summary. Okay, my port channels are all up. Let me check the internal switch. Do show the channel summary. Okay, my port channel is up here, so everything should be fine. it's up. Port channel is up here. Port channel 100. Ethernet 1.1. Port channel 100. It's up. Ethernet 1.1. And my show vPC again. Don't know why it's still giving me this. Show. Okay, please check down vPC step 2. Let me see. I'm not having, I believe that message is, I'm not having any issue here. Everything is okay from here. So that's all I need. Okay. For any view, okay, please check that if I have any issue. So, but now I don't have any issue. I don't have any inconsistency. Everything is okay. So you can see from vPC domain ID, peer adjacency has been formed. Peer is alive. So my configuration consistency status is success. Pavilion consistency status is success. And my type 2 consistency status is success. So I don't have issue. But in case if you want to check if you have any consistency issue, you can do show vPC consistency parameters. You can do global. So that global is going to compare. It's going to give you comparison. The local value. This is the local value. And this is the peer value. So this is for the other switch, peer value, which is the primary. This is for Nexus 1, which is primary. This is for the local switch, which is Nexus 2. So it's going to give you the comparison line by line. So if there's any error, you can easily discover where the error is. Maybe you're having type 2 error or whatever. You can easily discover that. And you can show can try to show you for a particular vPC, for a particular interface, for a particular VLAN. And for vPC, you can do show vPC role, you can do show vPC peer keeper life, and there it's going to give you so that's all the commands you need to know. Once you do your show vPC, you can use your tab key, show vPC brief, consistency parameters, internal fan ports if there are any, peer keeper live role, statistics, and the rest like that. So that's for that. We've implemented vPC on our Nexus, on our 2 Nexus switches, that's Nexus 1 and Nexus 2, and we've configured port channel on our internal switch. So another thing I need to do here is interface Ethernet 1, Ethernet 02 on my internal switch. I need to configure this interface and also assign them to the appropriate VLAN. So switch port mode access, switch port access VLAN 10, no shorts, interface Ethernet 03, switch port mode access, switch port access VLAN 20, no shorts. That has been done. So let me configure the test PCs. For VLAN 10, IP is going to be 192.168.8.10.10/24, and the gateway will be 192.168.10.1. The ASA is going to be the gateway. It's going to check for duplicate IP, and if there is none, so I'm going to save. So for this also 192.168.20.20/24, the gateway is going to be 192.168.20.1, which is going to be the ASA. It's going to be here. I'm going to save. So let me go back to my Nexus switch. Now there's something I want us to understand here. We need to understand it clearly. This is my ASA. These 2 interfaces will be configured to be member of port channel 1 on the ASA. So that means these 2 interfaces are bonded together. So I have one plug into Nexus 1. I have the other one plug into Nexus 2. And that's the reason why, don't forget, that's the reason why we implemented vPC. So that these 2 switches can be logically seen as one switch. So because it is then that this port channel will form, because they are supposed, it's going to be port channel will only form across a single entity. So because let's assume we didn't implement vPC between these two switches and we connect it this way, this port channel is not going to form here, because this port channel is not going to form here because there are two different switches. So that was the reason why I implemented vPC. So though they are physically they are different switches, but logically they are seen as one. So we are going to that's why I implement vPC. So these two interfaces belong to port channel 1 on ASA 1. So here, this interface on Nexus 1, I'm going to configure it to belong to port channel 200. And here on Nexus 2 also is going to belong to port channel 200. So these two interfaces belong to, and they are logically one. So this is port channel 200, port channel 200. They belong to the same port channel, and that means they belong to vPC 200, vPC 200. So then, if it is done appropriately, port channel will form across these two links on our ASA. So what I'll do is this interface Ethernet 1.5, no shots, and channel group 200 mode active. Interface port channel 200. Switch port mode trunk is going to be a trunk port. Switch port trunk allowed VLAN 10 and 20. No shots. So that I port channel 200, and I need to add it to vPC 200. I want the vPC to be consistent with my port channel number. So just for easy understanding. So show run interface port channel 200. Show run interface Ethernet 1.5. Okay, that's fine. Everything's okay. Show port channel summary. You can see this is it, but it's still on suspension. So we'll come back to that. So now I'll go to the to Nexus 2. That'll be interface Ethernet 1.6. Here is interface Ethernet 1.5, and here on the second switch 1.6. Channel. Okay, the interface is not shown down by default, but let me just do that. Channel group 200 mode active. So interface port channel 200. Switch port mode trunk. Switch port trunk allowed VLAN VLAN 10 20, and that will be vPC 200 also. So that is that. Show run interface port channel 200. Show run interface Ethernet 1.6. Okay, so that's fine. Show port channel summary. Okay, that's that. Let's come to the ASA. What's name? Let me the ASA. Okay, that's fine. And where should I start this from? Okay, I'll do interface Ethernet 00. Oh, Ethernet 0, sorry. So I'll configure this interface 00 let me unshort channel group 1 mode active. Okay, interface Ethernet 1, no short, channel group 1 mode active. So every other config that might have been, whatever config that might have been done before the interface is going to be cleared off. So that's the information it's giving us here. So now let me go to my interface port channel 1. The no short, and I'm going to create sub interface port channel 10. Oh, sorry, port channel 1.10 to represent VLAN 10. So I'm going to say VLAN 10. Name if inside 1. Security level, I'll give it 100. IP address 192.168.10.1 255.255. It's going to be /24. And the standby IP is going to be 192.168.10.2. So interface port channel 1.20, VLAN 20, name if inside 2, and it will be security level 100, IP address 192.168.20.1 255.255.255.0. Standby IP address will be 9160.20.2. Okay. Short should run interface port channel 1.10. Okay, 1.20. So for interface Ethernet 4, now will be name if outside. By default it will be 0, so it's 0 by default, so that's it. IP address is going to be 30.1.1.1, and standby IP address is going to be 30.1.1.30, and I'm going to do no short, show interface IP brief. Okay, that's fine. So now I'm going to go to my failover configuration. Failover LAN unit primary, this will be my primary box. Failover LAN interface, that's going to be the failover interface. I'm going to name it failover, and the interface is going to be Ethernet 2. Failover link, for my link, I'm going to name it, let me do link state, and it's going to be Ethernet 3. Whatever config that is on those interfaces will be cleared off. And again, interface, okay, I still need to ensure the interface. I'll do that later. Failover interface IP. So for failover, I'm going to do 2.2.2.1, 255.255.255.0, standby, 2.2.2, let it be 252, that'll be /30. Failover interface IP for the state link, that will be 3.3.3.1, 255.255.255.252. Standby will be 3.3.3.2. I made a mistake. It's supposed to be link underscore state. So that's why. So link underscore state. So that's going to be it. So run failover. Okay, so my interface is Ethernet 2, no short, Ethernet 3, no short, and I've still not done. Okay, let me leave this first. Let me quickly explain something. And there's a disclaimer here because it's a lab scenario. That's why I'm doing it back to back. In a normal production scenario, you want to connect your failover interfaces or your state link interface. You want to connect it to a switch. You don't want to, but especially for the failover interface, it's better you connect it to a switch. But because it's a lab scenario, that's why I'm doing it back to back. So I'm going to do failover, but I have not configured the second switch. So I'll just copy this, or this will be the same, I mean, on the second ASA node switch. So I'll go to ASA2. The only thing I'll just do is I'll unshort the failover and state link interface. No short. Even it's the failover interface that needs to be unshort actually, so that the failover can work. So after that, it's going to inherit every other configuration from ASA1. So failover LAN unit is going to be secondary. So I'll paste the rest of the config, and now failover. Just save this. Let me save. Well, it's going to detect an active meet now. Yep. You can see beginning configuration application sending to meet. You can see from here detected an active meet. Password okay with the beginning configuration application from meet, end configuration replication from meet. Show failover state. The house is still on box sync. By the time it's done, it's going to be on standby ready. Let's wait a while for it to finish its box synchronization. You can see now this host is active, the other host is standby ready. So here I'll do same command, show failover state. You can see this host is standby ready, the other host is active. So let me do show failover. Oh, I'm not monitoring my interfaces. I need to do that. Monitor interface inside one. You can see it's going to list all your interface inside one. I'm going to monitor inside two. I'm going to monitor outside, so that I can monitor the interface in case there's any failure. Failover can be triggered. So show failover. You can see now it has changed to waiting. So from waiting, it's going to change to monitor. You can see this is already unmonitored. The rest also. So let's just give it time. It's going to change to monitor. This is showing no link, but I'm having no link here, no link here. On the secondary host, show interface IP brief. This is secondary hosts. Why do I have it down here? Oh, I know the reason why. Now for the secondary host, we've not configured the interface on the Nexus part. So let's go back to our Nexus. For interface Ethernet 1.6 on Nexus 1. Oh, I'm on Nexus 2. For Nexus 2 is going to be 1.5. Channel group is going to be, I'm going to use port channel 201. Now, for ASA1 on Nexus, on this port and on this port, we use port channel 200. But for ASA2, we are going to use port channel 201. Because these boxes are two different boxes, the ASA. Had it been we implemented cluster between our ASA, the data interface will be seen as one. So we can do a kind of spanned port channel across the two chassis. But this is active standby. There are two different interfaces. So for this interface, we are going to use port channel 201. So now 201 mode active. No shots, that's all. So interface for channel 201. Switch port mode. Sorry, trunk. Switch port trunk allowed VLAN 1020 and vPC. For the vPC 201, should run interface for channel 201, should run interface Ethernet 1.5. Okay, so I go to Nexus 1, also interface Ethernet 1.6 on Nexus 1, channel group 201 mode active. No shots. Interface port channel 201. Switch port mode trunk. Switch port trunk. Wow. Okay. Switch port trunk. Allowed VLAN 10. I'm going to allow VLAN 10 and 20. vPC 201. So that should be it. Should run interface for channel 201. Should run interface for channel interface Ethernet 1/6. So that should be so port channel summary. K200 is up, but 6 is not up. Port channel 21 is not up yet. Okay, let me check from here. Show port channel summary. Okay, it's not up from here. Also, outside, should monitor that also. Okay, but that's showing monitor here. What's happening? I'm coming. Show interface IP brief. These guys are still down. Show run interface. Okay, 0 and 1 they are up. Port channel 1. Okay, there. It's from the switch side, but before that, 1.10. Okay, VLAN 10, this, and 1.20. VLAN 20. Okay, everything is fine. Let me go back to my Nexus switch. Show vPC. 2.1 is down. Something wrong. Let me do show vPC consistency. vPC 201. Channels on. Active 004 channel on disable this for boot trunk native VLAN boot 1 import trunk default. Lag ID, okay, disable, having the same parameters. Let me do it for Office port channel 201. Actually, same stuff. Before. Type 1. Okay, show run interface port channel 201. Show run interface Ethernet 1/6. Okay, that's fine. Yeah, show run interface port channel 201. Oh, no. This is promoter, allow 2201, 102201. Show run interface Ethernet. For this second switch, is going to be Ethernet 1.5. So what could be wrong? Show port channel summary. Okay, they're all up. They're all up from here now. I think it just takes time. It takes time to sync and come up. Okay, that's it. Success. So show vPC. Okay, everything is success. Everything is fine. For channel summary. Okay, so let me go to my ASA. ASA1. All my interfaces are up. Show port channel summary. Okay, the two interfaces are both up. 1. And on ASA2, all my interfaces should be up now. Show interface IP brief. You can see now they weren't up before, but now since the port channel has formed, see before they weren't up, but since the port channel has formed on Nexus, so they are up now. So our port channel should be fine here also. They are both up. So that's that. So now the next thing, we've done all the necessary stuffs here, so we move to the external device. Say interface range Ethernet 002. Not short. This is what I'll do. Okay, I'll just make it switch port mode access. Switch port access VLAN 30. No shorts. So interface VLAN 30, I'll create an XVI with IP address 30.1.1.30, 255.255.255.0. Show IP interface brief. So I should be able to ping the ASA outside interface 111. Nothing is being equal. I should do that ping. But I can't. Okay, it's administratively shut down. VLAN 30 is not yet up. Do I need to do interface? That means I need to unshut it. Port channel. Oh, sorry. Interface VLAN 30, no short. Okay. Duplicate IP address. Where Why duplicate address? That can be possible. I have, and here let me show interface IP brief. So there can be duplicate address. Let me ping 30.1.1.1. Okay, I can ping now. But it's telling me duplicate address. Source by this MAC address. Where's that coming from? I want to ping this standby ASA. Nope. IP interface brief. Turn 0001. Yeah, boot up. 001. So from the ASA perspective, show interface IP brief. These guys are up. Oh, here we are. 30. How come? Show run interface Ethernet 4. So I made a mistake. Interface Ethernet 4. I'll do no to this guy, and to this guy I'm going to do 2. I'm going to change it to 2. So I'm going to say, so everything should be fine now. Ping 30.1.1.1, and I should be able to ping .2 also. That's the standby ASA outside interface. So now let me create route, IP route. If you are going to 192.168.10.0, 255.255.255.0, you push it to 30.1.1.1. That's with the ASA, and same thing is going to .20. That is it. So gateway is route. So that should be all. Everything should be fine. So here now we have our ASA. Show failover. I don't know why. What's happening? Only my outside interface is being monitored. Inside 1 and inside 2 are not being monitored. Okay. And running this command. Okay, I'll do this. Okay. It's not monitored. It's only monitoring the outside interface. By default, it's monitoring the outside interface with no monitor command. Okay, that's fine. Monitor interface inside 1. That again. Inside 2. Show version. What code am I running on my virtual device? Okay, 9.1. Well, this is kind of a strange behavior. Show failover. Testing. Okay, it's testing it now. Let's see. By default, the outside is being monitored. So that's fine. It's going back to unknown. If you need to monitor, well, that's one of the issue we face sometimes if you are running or you're running on a virtualized environment. So it's a virtualized KEMU ASA KMU. So okay, so I'm going to leave that. So now my failover is still intact, and I've been able. The main thing I want to show us is this: implementing your active standby failover, integrating into Nexus, running vPC. Nexus has vPC implementation. So right now we can see what we need to do in order to get these interfaces working. Our port channel 1 interface, we are clustering our port channel 1 across these two physical Nexus switches, which are logically seen as one. So right now I've been able to show you what's needed to be done. So now let me do traffic test from here. This is my show IP. So I'm going to ping 192.168.10. Let me ping my gateway first, .10.1. I can ping my gateway. Why can't I ping my gateway? Show interface IP brief. My gateway is up. Show run interface Ethernet 1.1. Okay, show run interface port channel 100. Okay, Ethernet 1.1. Show run interface port channel 100. Okay, that's fine. Let me go to my switch. Show run interface Ethernet 02. Oh, no, this is external. I need internal switch. Show run interface Ethernet 02. Show run interface Ethernet 03. Show VLAN brief. Okay. So it should work. Why can't I ping 10.1? Let me ping myself first. I can ping myself. So why can't I ping my gateway? Okay, let me show VLAN brief for my Nexus. Do I have the VLANs created? Tough? I don't think so. Tough is 1.1. Okay, it's trunk. It's gonna be trunk port actually. Let's say 10, 20. Show interface trunk. Support channel 100 is trunk and 1.1. Yeah, fine. Trunk none. Okay. Okay, that's fine. I have the VLAN created now. VLAN 10. That's the issue. I don't have the VLAN created. So right now, let me go back. Let me try it again. Good. I can ping my gateway now. I can ping my gateway now, which is the gateway for these devices are on the ASA. Should also be able to ping the standby device. Be able to ping the standby IP. Now the next text is I want to be able to ping this SVI, but there might be something we need to do. 1.1.30. I'll do /t, that's continuous ping. From here also 30.1.1.30. I'm going to do continuous ping. The reason why it's not pinging, if I'm right, is because now by default this interface inside interface, they have security level of 100 and the other interface has security level of 0. So by default, traffic from security level of 100 is allowed to go to security level of to exit through an interface having security level of 0. But the case is true if the packet or traffic is TCP and UDP, because by default TCP and UDP traffic are inspected by the ASA. Then let's say I'm initiating telnet, HTTP, SSH traffic, is going to work. But because it's Icmp is not inspected by default. So let me just show run policy. Show run policy map. But let me just get it from here. From this guy, from here. I'm going to inspect Icmp because if you see Icmp is not being inspected here. So that's what I'm going to do. Just paste that. And now say inspect Icmp. Instead, I can decide to use ACL, but I don't want that. That means I also, if I'm using ACL, that means I'll put ACL on the outside interface to allow the echo reply to come in. So I'll just do inspect Icmp. So doing that, the ping should work. You can see the ping is working now. Ping is working, the ping is working. Well, you can see our interfaces are being monitored now. I think it just takes time because although actually is an emulation, is a virtual device, so that's why we had that issue. But now you can see, although the outside is being monitored by default, we have also configured monitoring for the inside one and inside too, and they are being monitored. If you look here also, show failover. Okay, all our interfaces are being monitored. So, and our continuous ping, they're all fine. So let me do something. Now this is